Now, so far as the frequency division multiplexing is concerned, as we shall see, for frequency division multiplexing we use analog signaling. That means, we generate signal by using by using FDM and WDM technique, and it can, I mean, the analog signaling is used in two different techniques, FDM and WDM, and as we shall see, the time division multiplexing is done by using digital signaling, and that is why it is called TDM, and ATM stands for asynchronous time division multiplexing. So, we can say that analog signaling is used for frequency division and wavelength division multiplexing, and digital signaling is used for time division and asynchronous time division multiplexing. Let us see the frequency division multiplexing technique in details. What we do, first divide the available bandwidth into a single physical medium into a number of smaller independent frequency channels. So, the available bandwidth is divided into a number of smaller independent frequency channels. So, that is the first thing that is done. Then using modulation, independent message signals are translated into different frequency bands. As you have done, as you have seen, by using modulation this can be done. That means, independent message signals can be translated into different frequency bands. Then third thing that is done is, as all the modulated signals are combined into a linear summing circuit to form a composite signal for transmission through the medium which has higher bandwidth. Finally, the carriers are used to modulate the individual message signals. Okay, the carriers used to modulate the individual message signals are called subcarriers, as we shall see. So, here we are not using a single frequency carrier, but a number of frequency carriers, and we shall, as I mentioned, we can use one of the three different techniques: amplitude modulation, frequency modulation, or phase modulation. One of the three techniques can be used to generate analog signal and to translate the individual frequencies to different frequency bands by using different carrier frequencies. On the other hand, if your data is digital in nature, then you can use ASK, FSK or PSK, or a combination of ASK and PSK to generate analog signal, which is known as QAM. So, depending on whether your data is analog or digital, you will be using either amplitude modulation, frequency modulation, or phase modulation if your data is analog in nature. On the other hand, if your data is digital in nature, then you will use ASK, FSK, PSK or QSK to convert to generate the analog signal, as we have discussed in detail in the previous lectures. So, the basic frequency division multiplexing operation is explained in this diagram. Here you have got source 1, source 2 and source n sources, 1 to n sources. Now, each of the frequency band of each of the signals is shown here. So, that means it is like this in the frequency domain. Now, as you do the modulation by using a frequency Fi, as we know, after amplitude modulation the bandwidth becomes like this around Fi. So, the bandwidth becomes double and the frequency of the carrier is Fi. That means, here is the frequency of the carrier is Fi. Now, we are modulating different signals with different frequencies. So, these are known as subcarriers F1, F2 and Fn. So, you can see here, if the bandwidth, transmitted bandwidth is from here to here, we can send all the signals F1, F2 and Fn, all signals can be transmitted through the medium. So, here after modulation we are combining and then sending through the transmission media. If it is air, then you do not have to do this, because all the signals will be sent through the air, and at the receiving end the separation can be done by suitable technique. As it is shown here, we are receiving the different signals F1, F2 up to Fn. So, these signals are received, and then with the help of demodulator they are separated out, and the demodulator then separates out each of these signals carriers F1, F2, Fn. So, here you get different frequency bands. So, say for example, here the frequency carrier frequency F1 is filtered, here the carrier frequency F2 is filtered, here the carrier frequency Fn is filtered. So, they are filtered out, then they are sent to different destinations. And here it is shown in more details. So, the carrier frequencies Fc1, Fc2 and Fc3. Apart from having different bandwidths, separate bandwidths for each of these signals coming from different sources, you will some extra overhead is there, which is known as guard band. This guard band is necessary so that channels are separated by strips of unused bandwidth to prevent inter-channel crosstalk. If the channels are very close, then the signal of one channel will disturb the signal of other channel. Sometimes we observe that in our whenever we receive radio signals, that adjacent channels are so close that if the filtering is not done properly, then it disturbs the signal of adjacent channels. So, that kind of thing can happen. So, to avoid that, we have to use guard bands between each of these bandwidths, as you can see, that is required for each of the signals. So, if you have to take care of not only the bandwidths of each of these subcarriers, but also the bandwidth of the guard bands together to decide the bandwidth of the channel. That means, the channel must have a bandwidth which is sum of the individual channel bandwidths plus the guard band bandwidths. And frequency division multiplexing has found applications in our day to day life. As you know, transmission of AM and FM radio is done by using this technique, and with the help of the radio receiver you can tune different channels. That means, you can select different frequencies and listen to that particular channel. So, AM and FM radio broadcasting it is used. Similarly, it is also used in TV broadcasting. In TV broadcasting also you can select different channels with the help of the tuner of your TV and watch different channels. And in cable television, same thing is done through a coaxial cable. As we know that each channel will require about 6 megahertz, and as we know a cable can provide you a bandwidth of about 500 megahertz. So, through a single coaxial fiber, coaxial cable that is being used,